So please welcome Abdel.
Abdel.
Hello. Ciao. Can you hear me?
Yeah.
Yes.
Yeah, okay. Well, ciao. Okay, good.
Ciao is the right word.
Okay, so I promise that's as much Italian as I'm going to speak today, okay?
That's enough.
That's more than enough, I guess. All right,
That's
cool.
way more than enough. All right. So, how are you feeling about this talk? How are you feeling about Florence?
Florence is amazing. I went for a run this morning around the city. It's pretty cool. Yeah, it's really nice.
I saw the picture. It's really nice that you posted. And enjoy the show.
Thank you.
Thank you for coming. And I know it's not easy in these days, thanks to the strikes in all over Europe. So thanks, Air Company.
Thank you.
But so, the stage is yours.
All right, thank you. Well, hello everyone. So I'm gonna do a demo. I promise I will do a demo because I've done this talk multiple times. So when you were asking me about how I feel about it, I'm like, I've done this before, so it's not really a big deal. But I want to do a demo because I want to leave you with something concrete. A lot of the stuff that I cover in this topic of software supply chain security is pretty theoretical, really. It's a lot of basic knowledge that I think everybody should know, should be aware of. And there are very valid reasons why you should be aware of this stuff, especially if you are actually a developer in Europe. I'm gonna, before I get going, I assume everybody here is a developer. Raise your hand if you are a developer. Okay, so everybody. Sysadmin, DevOps, DevSecOps, security, kind of cloud, machine learning people. Okay, majority developers. So everything that will be covered in this will impact you in a way or in another. And then one of the reasons is because the European Union actually passed some laws to make these things mandatory for EU countries. And Italy being an EU country, these things will impact you. So my name is Abdel. I'm a developer advocate at Google. I've been at Google for 10 years. Almost 11. I live in Stockholm, Sweden. So I came all the way from Stockholm. It's not like I didn't really have to I didn't walk. I took a flight. So it's not, I'm making it look like it was a big effort. So I've been at Google for 10 years. I'm mostly focused on containers and everything around containers. Kubernetes is one of the projects I work on quite a lot. And the demo I'm going to show today is really about containers and Kubernetes, but the concepts are really kind of valid for pretty much any environment you are using. I co-host a podcast called the Kubernetes Podcast by Google. It's not only about Kubernetes. We talk about all sorts of topics. I don't know if you are doing things with machine learning. We have done this before. If you are doing stuff with feature flagging in programming languages. We have an episode coming about that. I just finished it last week. So we cover quite a lot of topics, databases, all sorts of things. And I curate a newsletter on LinkedIn called the GKE newsletter. Again, not only Kubernetes. I basically cover pretty much everything. And that's my Twitter. I mostly complain about things, and sometimes I share useful information. So what is this about? What's the point? So this is not new. Software security is a very, very big problem. It's a challenging problem. And to make it very concrete, I'm going to talk about actual examples. You all have heard of Log4j last year, right? Everybody have heard about it? I don't know how many people have heard of SolarWinds. SolarWinds? Yeah, so 2-3 people. So for those who didn't, SolarWinds is a company that produces software, and they were impacted by an attack last year. And one of their downstream customers is a company called Continental Pipeline, which is a company that supplies the East Coast of America with oil. And so last year, Continental Pipeline, being a customer of SolarWinds, was actually impacted, and they had their IT systems down for a week. And what is super interesting, I think, in my opinion, about all these software supply chain type of attacks, beside the fact that how they are getting carried or how they're getting executed, is the impact they have. So we all have lived in, I think, pretty much I'm looking around, everybody's pretty much the same kind of age as myself. So we all grow up and came to this tech field as getting used to security problems literally means hacking. You steal some data, you leak some passwords, you leak some data. And that's kind of the extent the extent of the impact in a way. But what's really happening these days is that all these security problems are having real-world impact. So the Continental Pipeline is a very good example, because when that attack was carried and the company was down for a week, a lot of people actually freaked out because people thought that there will be no more gas available in gas stations. And in a lot of gas stations in the East Coast of America, there was like queues for 2 hours. People were queuing so they can stock up on gas, right? And before we go too far, this is an example that happened in Sweden. I've been living in Sweden for 6 years. I have to go to supermarkets like any of you. There is a big supermarket chain called Coop. It's one of the biggest ones in the country. I don't know how much you know about the geography of Sweden, but Sweden is a super big country. And a lot of people actually are concentrated in very few areas. There is actually, statistically speaking, if you go north of Stockholm, the capital, by 80 kilometers, there is a city called Uppsala. If you draw a line, 90% of the population of Sweden lives under that line. So 90% of people live actually south of Uppsala. Why I'm saying this is because Coop, being a very large supermarket chain, they have supermarkets everywhere, including in the north of Sweden and in some of the most remote locations. Last year, I was very lucky. I actually traveled all the way up north to Sweden in a car, and it's basically a no-man land. Like there is, like you could be driving for hours, literally, without seeing any other human souls. It's extremely remote, and they were impacted, and some of their stores were closed for up to a week. So what happened? So Coop has a bunch of cashiers, like the place where you scan your articles to pay for them, but also the self-service ones, like the one where you do the scanning yourself, right? And those machines, they are computers, they were managed by a third-party company, and that third-party company used a software called Kaseya. Kaseya is an IT management software, so they use it to like scan the inventory management kind of thing, like patching and stuff like that. And that software was impacted by a supply chain attack, which then they released a patch, and that patch went to the IT company, which then went to Coop. And this is just an example of what I'm saying, that supply chain attacks could have real-world impact. In this particular example, the real-world impact is that supermarket chains were closed for up to a week, right? And this is actually a very big problem because in some parts of Sweden, Coop is the only supermarket chain they have. So if a village doesn't have a supermarket for like a week, they might risk not being able to eat, or they have to travel very far to actually get food. So why? Well, because the way we build software today is extremely complicated, and it's kind of like Lego. Almost no one here is writing software from scratch. You all download dependencies from the internet, right? You all download some sorts of open source dependency through your dependency management system for your programming language, and you use that to build, package, and run your software. But what a lot of people don't actually realize is that it's possible that even your dependencies are built the same way. So it's kind of like a cyclical problem. The dependencies are following the same process to be released that you are using to actually release your software. And so before I go further, because everybody here is a developer, like when we say supply chain, we literally mean CI/CD, right? It's just a very fancy term that says CI/CD. It's a marketing term. You don't have to worry too much about it. When people say supply chain, it literally means the process by which you are getting software from where it's produced to where it's needed, right? It's CI/CD, right? Like the whole process. Automated, not automated, doesn't really matter. And so there are many ways in which this supply chain could be exploited, right? You could be starting with vulnerable packages. You download a vulnerable package. A few years ago, everybody who uses Mac uses Homebrew, right? So a few years ago, somebody who is actually a security researcher committed some code to the Homebrew GitHub repository, and after a certain number of commits, his account or her account, the account of this security researcher, became a committer automatically. And this was way before GitHub, way before people used to care about master or main branch protection. So if you become a committer to a code repository, you can just commit code without pull reviews or pull requests, right? And so this person was trying to demonstrate how easy it is to hack open source. So he committed a bunch of code and then eventually became a committer and then disclosed the fact that, hey, this is not protected properly. Anybody who becomes a committer could just push whatever code they want. And if you push a backdoor to Homebrew, well, basically everybody who has Homebrew will have it. And we all know that one of the ways Homebrew works is that next time you run Homebrew, it will update itself, right? You never update Homebrew. It updates itself automatically whenever you run it. So yeah. You can also have a package that you download that is vulnerable, but you don't detect it. You do static code analysis. You do all the sorts of checks that you want to do, and you don't realize it. And then by the time it runs in your production, it will download something. It could be like a base 64 encoded URL wrapped into a function that we just like download a bash script and then run it. It could be any sort of like auto updates done in production. You could also have vulnerable code source. So I'm gonna for you the developers here who are from Italy. does companies in Italy typically do background checks? Is it something that people do here? Like before getting employed in a company, would your company go check if you have like criminal history or any sort of things like that? No? Okay. That's very interesting. Okay, I ask this question every single country I go to, and depending where I go, the answer is usually yes or no, or it depends. In Sweden, they do it, but only for like banking sector or like some sort of like healthcare sector. But in a lot of countries, we just basically assume developers are like nice people, and we just hire them based on the face value that they are nice people. But like, I mean, I'm not trying to say this is not. I'm not pointing fingers at anybody, but people are humans, and you might hire people who are trying to like legitimately hurt you. It's a thing that people are not aware of and people don't even care about. And it's a really big problem. And so yeah, so the TLDR or the story is basically this supply chain can be vulnerable to many types of attacks. You can have bad code, bad dependencies, a compromised source code system. The Homebrew example I gave is an example of a compromised source code or like a source repository, code source repository, sorry. Compromised packaging system. How many people here use Circle CI? Do you know what Circle CI is? No one? Okay, good for you. So Circle CI is a CI company. It's a CI platform, managed CI platform. And last year during Christmas, not last year, 2023 or 2022, I don't remember. They actually had a vulnerability, or they were hacked. And they leaked, okay, so this is gonna be funny. They leaked their customers' AWS keys. And they leaked their own AWS keys. So they run on top of AWS. They leaked their customers' AWS keys, but they leaked their own keys as part of that vulnerability. And they did not detect it for 2 weeks. I think they were a little bit too drunk on wine and ham during Christmas. It took them a while. So what I'm trying to demonstrate here is like you should never actually just blindly trust whatever you're using. Things can go wrong. So now what? How do we solve this? Well, what's been happening over the last couple of years is that security people have been trying to implement some methods to try to fix this problem. And there are like two big kind of types of methods. I'm going to show one today. It's called zero trust. So zero trust in software supply chain literally means that you don't blindly trust software as it's moving through the supply chain process. As you are getting code from the developer laptop, building it, testing it, doing your checks, doing QA, running it in production, you have to check that software have been coming from a trusted source through this entire process. And I'm going to show you an example later. And then shift left essentially means making sure that developers are aware of what they're doing, giving developers visibility into what they're doing. And there are actually tools to do that. And I'm gonna talk about some of them. So there is one company or one effort that is kind of becoming the champion of this. It's called Sigstore. So this is a community effort between multiple companies. There are a lot of companies involved in it. And what they're doing is they're building two types of things. They're building processes and tools. And so this is kind of like their components, they call them. So quickly talking about, I'm going to show Cosign today. It's one of the tools I really like, and it's kind of straightforward to use with containers. But they have things like Recore, for example. So Recore is a public ledger. It's essentially a website where you can log in and you can check if a dependency that you are trying to use have been signed and who signed it, right? You could, of course, if something have been signed by somebody, they can publish the public key, and then you can use the public key to verify the signature. But Recore is a public ledger. It's a read-only ledger. And you can go there, and if the library you are using uses Sigstore components, there will be a trace somewhere that says this version of the library have been signed and who signed it. They have a public key infrastructure like certificates and keys and stuff like that you can use to do these kind of things. And so this is how they think supply chain security could look like or should look like. So this is the Sigstore edition. Sigstore is focused on open source. So all the stuff they do, they're for open source. But essentially what it means is as a developer, you use a certificate to sign an artifact. An artifact could be a binary, could be a library, could be whatever. And then you publish that signature somewhere. You say what it says on the top signed artifact. You publish that signature somewhere with the artifact itself. And then whoever is going to use it, the end user, can download the signature and download the artifact and verify that the artifact have been signed. I have a very, very dumb example to show you, to explain what this actually means really in kind of layman terms. You know, when you go somewhere to download the binary, sometimes you have the option to download an MD5 sum or a SHA 256. And what you're supposed to do is verify if that binary signature matches the file you downloaded. This is just a complicated version of that. This is exactly the same idea, but using certificates and using keys instead of just a random text file. I'm going to show you an example. They also have something called SLSA, which literally stands for security levels of software artifacts. So it's a framework that you can implement to your CI/CD system, to your supply chain system, which basically you see on the left side, you have a bunch of requirements, and on the top you have SLSA level 1, level 2, level 3, and level 4. And if your supply chain matches or meets all these requirements, you can say my supply chain is SLSA level 1, 2, 3, or 4 compliant, right? And so we can take an example. I don't like to spend too much time here. You can read it online. But basically, SLSA level 3 means that your source code is versioned. You have a verified history. Verified history basically means there is a tool called gitsign. If you care, you can look it up later. Gitsign is actually a command line tool that can allow you to sign your commits. So when you commit something to a source code repository, whoever looks at the commits can verify that they're coming from you and not from somebody else. Just an example. GitHub does support it, so you can actually, if you have a GitHub repository, you can configure it to reject commits if they're not coming from a signed source. Your build system, which is in the middle, is ephemeral, it's scripted, blah, 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 isolated, all that stuff. It's like a bunch of requirements. It's literally a checklist. You can go through it and then just like match those requirements one by one. And the last key to this puzzle, if you say, it's literally a puzzle, it's like a bunch of components that can be used together, is something called SBOM. So there is many, many ways people like to explain SBOM, or as, I was in a conference a few weeks ago and somebody was calling it SBOM for some reason, because they didn't feel like saying SBOM literally. SBOM, I hate it. So SBOM stands for Software Bill of Material. So the very simple example of explaining that, I had, my dinner yesterday was a Toscan, it's called Peposa? Peposa something? It's like a stewed, like lamb, like beef stew, like whatever. Think of your grandma favorite recipe, right? Think of whatever your grandma taught you how to make something. So the way your grandma passed you this recipe is a list of steps and a list of ingredients. So you go to the supermarket, you buy the ingredients, you come home, and you follow the steps to reproduce the dish. In software engineering, the ingredients are the dependencies, right? The actual libraries that went into building this artifact. So a SBOM, or Software Bill of Material, on SBOM, is literally the list of ingredients. It's actually the thing that your grandma taught you to write. And the key difference between your grandma favorite recipe and software is that your grandma recipe is a recipe that you can reproduce multiple times, and hopefully if you don't screw it up, the results will be the same. Software Bill of Material is individual to every single artifact, right? The way an SBOM is built, it's literally specific to that specific artifact. And if one thing changes in the artifact, the SBOM should change. Make sense? So, you remember in the beginning of the talk, I said that this is going to be important for people who live in Europe. So there is a law that passed in the European Union called NIS2. And in the NIS2 law, they are actually going to make it mandatory for companies to store and be able to supply SBOM if required by regulators. This is coming in 2025, and you have to produce and store SBOMs for 10 years. And it's only going to be for some sectors, so banking, healthcare, energy. Like if your company works in certain sectors. Now, when I say this typically to people, a lot of times people, like especially developers, they're like, well, okay, this sounds like too much work. What can I do with SBOM? Why is it useful for? Okay, the EU asked me for, like who cares, right? So actually, one very good way of using SBOM is if you produce SBOM for your artifact, you can just think of the data coming out of SBOM, because literally SBOM is a file that follows a format. There are two types of formats. There is SPDX or CycloneDX. It's literally just a text file, which each line is like one artifact or one file. The signature, the GitHub repository, the author, and maybe this like who produced that artifact. And so you can take all this data and store it in a data warehouse. And you will be able to answer questions like, am I using a software that is using a certain types of license? If your organization has licensing restrictions, like for example, you cannot use a software that uses BSL, which is a business software license. It's the license that HashiCorp switched all their software to very recently, Terraform. It's not open source anymore. It's part of this thing called BSL. It used to be Mozilla, I think, or MIT, and now it's switched to BSL. So storing the data, you will be able to answer in a big data way, query a database and say like, am I using a dependency that is using Apache 2, for example, or using GPL3 or something like that, right? And when you have a problem like log4j, you will be able to query your database and go like, where is log4j version blah, blah, blah used? And then you will be able to have visibility across all your organizations. The reason I'm saying this is very important is because the way actually we're building software these days, right, is everybody works in an organization, but you usually have a GitHub org, and under this GitHub org, you will have hundreds or thousands of GitHub repositories. And you cannot possibly go through every single one of them and look at every single dependencies, right? So using something like SBOM as a source of data, you will be able to answer these kind of questions. So SBOM, SLSA, put together is one of the answers to these software supply chain challenges I've been talking about. You don't have to implement all of it. They are complementary. You don't have to opt for one or the other. You can opt for whatever you want. And even SLSA, you saw it's a checklist, so you can actually opt for SLSA gradually, like one step at a time. So I'm going to show an example here of what I mean by this. So for those of you, how many people here you know what Kubernetes is? Okay, few of you. Good. Okay. For those who doesn't know what Kubernetes is, whenever I use Kubernetes in this example, just think about it. I am SSHing into a server and running somewhere, okay? I don't want you to worry too much about how it works, right? For those of you who know Kubernetes, you know that basically I can just do this. Give me 1 second. I just need to do that and that. Okay, good. And I have a key, so I don't have to worry too much about it. Let me see, do I have an image here? Ah, yes, I do. Okay, good. I have it. It's already tagged there, so that's pretty good. So actually, you know that I can just do this. I can do something like kubectl. That's the command line I have to use to interact with Kubernetes. Deploy. Give me a second. Do I have something running first? Yes, I do. And then I will delete this. I'll just delete it and then create it again. Kubectl, create, deploy. I'm just deploying something. I'm deploying something. I call it Nginx. And here is where things get a little bit scary. I just do -- Nginx. And for those of you who know Kubernetes, can you tell me what's the problem here? What do you think the problem, what I did is? I just deployed something coming from the internet, right? I just say, hey, deploy an image, and the image is basically literally Nginx. I did not specify where that image is coming from. And for Kubernetes, basically, if you don't tell it where to pull the image from, it will pull it from Docker Hub, right? And we all know that Docker Hub is to not be trusted. I mean, you should know that it's not to be trusted. This could literally mean, I could basically say something like, deploy this, and then hacker account / and it would work. Kubernetes doesn't really give a damn. It's just like, okay, whatever. You want to deploy something, I'm able to download the image. I will just run it for you, right? So, of course, now I have my non-trusted container image running there. I don't want that, so I want to avoid it. How do I do it? So, one thing you could do is you could, let me show you something real quick. You could sign an image. So how would you sign it? What does it mean actually to sign an image? Signing an image literally means you add a signature to the image that basically verifies cryptographically the image itself. And so I do have an image here, which I'm going to have to delete because I need to 5 minutes? Okay, thank you. I need to do it. I think I will be able to finish before 5 minutes. So what I'm doing here is I'm pushing an image here, Docker push, right? I'm just pushing an image, and I'm grabbing the signature, the SHA. So I'm just going to wait for it for a second to be pushed. And once it's pushed, I'll be able to see it here. Okay, good. I have my image. And so one way I could establish trust that I talked about earlier as part of Zero Trust is I could use cosign. So cosign is a command line tool. It takes 2 inputs. One input is the actual image, and the other input is the key to sign the image. The key could be coming from anywhere. It's very agnostic. So you can use your own key. You can use the key coming from your own HSM system, or you can use a cloud key. In this case, I'm using a key coming from Google Cloud. Every single cloud provider has a KMS, a key management system. So I'm just using one coming from GCP, but it supports all the cloud providers. So I will be able to run my sign function, And, oh yeah, sorry. Hold on a second. I have to do this. Hopefully, this is not going to take too much time. Come on. No, why do I need the... Okay, I hope I'm not going to show you something embarrassing. Good. Okay, good. I'm not supposed to show you this code here, but whatever. That's little. If you take that code, you can actually take over my projects, by the way. So I'm going to assign my image here. And so basically what this will do, it will generate a signature for the image itself, and it will push it and add it to my image as metadata. So if I go here and I refresh, I should have... here. It's the new layer. It's the last layer. And if I go into the manifest, it's essentially just a JSON payload, and in the JSON payload there is a signature, right? And so if I change my container image, if I change one thing in the container image, the signature will change. And so what I can do with this is I can actually later on down the pipeline. So for example, you can imagine this done as part of your build, and then somewhere after the build, you can just run a verify command, and the verify command will just verify the signature against the key, and then it will exit with 0 if the signature have succeeded. It will exit with 1 if it didn't. So you can basically run a verification. This is zero trust. I built a container image, I signed it, and somewhere I verified the signature. I can go further, and I'm not going to go, I'm going to just show one more thing, and then I want to leave time for questions. In Kubernetes, I can deploy something called the policy controller. A policy controller in Kubernetes is essentially a component that will verify certain conditions are met before it allows you to do stuff. In this case, I have a policy controller that I can configure, and I can tell this policy controller, for all the images I am deploying, please verify the signature against this specific key, right? And so the last thing I need to do is I need to create a namespace and label it. I can show you the details later. It's already there. And so inside this namespace now, I'll be able to do... if I try to do, for example, you remember earlier when I did that deployed that Nginx image? If I try to do the same again in that test namespace, this should fail because the Nginx image will not pass the policy that I have set up because it's not signed, right? But if I try to deploy the image I signed, it would succeed. It's already deployed, so I'm not going to show it. But essentially, the idea is that you have a cryptographic way to sign an image, verify its signature, and then later on make sure that the image does not get deployed if it was not signed by the source you said it should be signed with. And yeah, that's it. That's all I have, I think, for you. If you have any questions, they're welcome. Thank you.
Thank you for the great talk. And I don't know about you guys, but I take it as a compliment. But you remind me about the skill, about the writing type, the writing style, and also kind of the hairs that you have. Matteo Collina, do you know him?
Who?
Matteo Collina.
No.
No?
No.
I mean, he's just a guy. I don't know. Do you know Matteo Collina, who he is? All right.
Okay, Matteo. Okay.
Matteo Collina. Yeah, you can Google it. Google it.
How is it? How do you write it?
Matteo Collina. You just say Collina Node.js, it will appear. Like God.
With a C?
Too many, yeah. With the O.
Collino.
Like. No,
okay.
We are making some jokes in Italian. No.
Let
me just.
Collina with an O. Okay.
Yeah, this guy right here.
What is the joke?
Yeah, you were writing something that could be.
So what I wrote before. Okay, got it.
Yeah.
Maybe somebody can tell me later, not on stage.
Yeah, but I don't know.
Yeah, we do look like.
There are some similarities.
Yeah. Okay. He looks a little bit brown like me. I'm from Morocco, by the way, if you are curious. So.
Nice. But yeah.
Okay, sure. I mean, I don't write code, no JS code, but I'm a Go developer, so.
Yeah, but I mean, the coding style that you have, that you showed in the demo, it was kind of the same.
Cool.
So
Good, thank you.
Take it as a compliment. All right, so first of all, the trophy.
I was looking at those. Thank you.
Here
That's awesome. Thank you. It's 3D printed. I love 3D printed.
Yeah,
Thank you very much.
3D printed.
Awesome. And also, I have to compliment the badge design. This is one of the best badges I ever had in
thank
conference.
you.
It's
Thank
amazing.
you. So thank Andre for the Schrodi trophy, and thank you, Mattia, to bring this design.
Thank you.
So, going back to questions, you were watching me because you have a question? Of course, he does. So here we go.
Thank you for the talk. I was aware of SBOM, but not salsas. And I'm wondering, is there any tools to write salsas and SBOMs, like automatically? Like I'm thinking about what the package JSON is to NPM or the PyProject TOML, like, because they tend to get outdated if you don't do it all the time that you introduce a new dependency.
Yeah. So there are multiple tools. There is a tool called Sift. This is one of the tools, Sift, SYFT. It's a tool to generate SBOMs. This works with container images, right? But if you are using for example, for Go, you can use something called Canico. So Canico is a packaging tool for Go. If you're writing Go code, Canico allows you to package Go code as containers without running Docker files, without writing Docker files. It will package the container automatically for you. So this also has a feature to generate SBOMs. And if you're a Java developer, Maven has a way to generate SBOMs. So the answer to your question is there are tools that work generically speaking. So Canico and Sift is an example. But there are also language-specific tools. So for Java, Maven is a tool to generate that. So it really depends on the programming language. I think I used Canico before. It works very well, but I write just Go code. For Java, I know that people use Maven. It's pretty popular. But then, yeah, I don't know about the other languages. But there's like tons of tools. It really depends on the programming language. Other questions? While I'm taking a picture.
Don't be shy. No one?
It's either everybody understood everything I said, or no one have an idea about what the fuck I was talking about for the last 30 minutes. But I'll be here for the whole day if you have any questions. Yeah, tell me.
Thank you. Actually, I've lost the part where you signed the image. Okay, so I just wanted to know how you did sign the image.
So I used a tool called Cosign.
Okay, perfect.
See?
Okay.
So I used a tool called Cosign.
See.
So that's the tool called, it's Cosign, how I signed it. So Cosign, sign, the key, and the container image.
Okay.
Yeah.
Thank you.
The tool is called Cosign. And yeah, and Cosign works for container images.
I haven't read the region and the second part of the command. Okay.
Yeah, so it has a sign function and it has a verify function. And it has a bunch of functions. It also has, I didn't show it, you could also use Cosign to attach SBOM. So the question of earlier, if you generate an SBOM, you can also attach SBOM to the container image as metadata, and Cosign has a command line for that. So you can just do attach SBOM, and you give it the input, and it will attach it as a metadata to the image.
Thank you very much.
No worries.
Oh, I was about to ask a question, but you go first.
Hello. So I've never used Kubernetes before. Is there a way to kind of get started with it and like without having to pay like a subscription?
Without having to pay?
Yeah.
Oh yeah, there is multiple ways.
Oh, great.
There is something called Kind, which stands for Kubernetes in Docker. Actually, I don't have to look for the web page. I think I can show you. Let's see. Do I have Kind deployed? Yeah. Kind. Oh, I don't even remember. Yeah, but anyway, sorry. Yeah. Kind is one way. Kubernetes in Docker. So this will will deploy a Kubernetes cluster inside the Docker image on your laptop. So you have Kind. You have Minikube. There are three main tools I recommend people to start with. You have Kind, you have Minikube, and then my favorite is something called K3S. K3S, not K32. So you can do Kind, you can do Minikube, and K3S is my favorite. The reason I like K3S, K3S is from Rancher, a company called Rancher, which I think is part of Red Hat right now. It was purchased by Red Hat, I think. Why I like it is because it's super lightweight. It's 100% Kubernetes compliant. So if you deploy it and use it, it will behave the same as if you're using Kubernetes on any cloud provider. And it allows you to run like a real environment. So you can run multiple nodes. You can do 2 nodes, 3 nodes, 5 nodes, whatever. And everything is run inside Docker. So everything runs as a container image.
Abdel, I hope you try out NanoSeal.
Sorry?
I hope you try out NanoSeal. It's my project. That's the alternative.
Oh,
to
I
Kubernetes.
didn't. I don't know which one is it. I don't know it.
It was in the morning, so perhaps you missed it. It's
Probably.
fine.
Yeah, I was not. I just came in the afternoon, so
Yeah,
then
it's
I missed it for sure. I will look it up. All right.
Yeah, right. I believe it was acquired by SUSE. SUSE.
Rancher?
Yeah.
Rancher
No?
is part of SUSE now?
No.
Yes.
Okay. Rancher
It's
is
right?
part of SUSE. I didn't know that. I thought it was.
Maybe I'm wrong. Huh?
Yeah, it's SUSE. You're right.
Yes.
SUSE,
Yes. Yeah, it
yeah.
is. Okay. Well, SUSE still exists. I didn't know that.
That's nice. We have the director, which comes from SUSE, which is...
Sorry. Okay. Do you work for SUSE? Okay, good.
He was the
So
guy...
this is, you are in Florence. I didn't know that. Okay. I'm just kidding.
He was the guy that signed the deal.
You signed the deal?
No.
But investment, I'm just kidding. I'm just kidding. I have a SUSE t-shirt. I used to be in a previous life, I was a Linux sysadmin before DevOps was actually a thing. So, all right. Well, grazie mille. Thank you. Thank you very
That's
much.
it. Thank you.